Okay, and we're going to continue our study with our study of functions with piecewise functions next. Or all piecewise functions are is functions defined in pieces. So, for example, here we have two different branches, and we call each different function a branch in piecewise functions. So, in the first branch, corresponding to the domain when x is less than -1, the function behaves according to 3x minus 1. And then when it's greater than or equal, when x is greater than or equal to -1, it behaves according to the function 2x plus 1. So, for example, if we have f of -2, well, we have to figure out which branch that is in. -2 is less than -1, so it behaves on that domain, it behaves according to this function. So to evaluate it, all I would do is substitute in -2 into that first branch, and I'd get out a -7. Now for the second branch, at -1 now, -1 is the place where the function changes from 3x minus 1 to x plus or to 2x plus 1. The key here is we need to look where it's equal to -1 because it's saying the x value is or equals -1. Okay, so I look at my function and -1 or the second branch has equality. So then I would use the second branch to evaluate this and substitute in -1 and get out a -1 as a result. Okay, so piecewise functions we will see quite often in this course. In particular, we are going to be focusing on piecewise linear functions. And so these are especially useful when we have data points from a known function, but we don't know exactly what the function looks like. But what we can do is to estimate that function, we can actually make lines in between the data points, just like so. And if we can determine the equations of the line, we can have some sort of approximate idea of what the function is doing between those data points. So the piecewise linear function that we're going to make is going to have 3 branches. And so we need to find the equations of each part. So if I look at the first part, if I look at that first line in blue, I first need to determine the slope. I have 2 points, so I can use point slope form. I just need to know the slope, and to do that I'm going to do let's see, I'll start with 1 minus a -2 divided by, and let's see, I started with this point, so -3 minus a -4. Okay, and I'm going to get a 3 over 1, which simplifies to 3. So then the equation of the line, and I'm just going to rewrite this up here so we can reference this. And I'm going to switch point slope form slightly. You can show this just through algebra. And I'm just going to add the y1 to the other side, because normally we would have the minus y1 on the other side. But I'm just going to add it over here. So the line for this section is just y is equal to 3 and then x, and I can choose either point. I'm going to choose this second point here, so that'll be a plus 3 plus 1. Okay, and making that second one the second equation for a line, or the equation for the second line segment, I should say. We determine the slope first, as we did with the other one. So let's see, we start with the second point, or whichever one you want, as long as you're consistent again. So the y value of 0 minus the y value of 1 over the x value of 1, of course, I have to start at the same place, minus a -3. Okay, and here I get out a -1/4. Okay, so then the equation for this line is y is equal to 1/4 negative x plus, or x minus 1, and then plus 0, so I'm just going to leave it like that. Okay, and when all is said and done, I'm not going to go through the third one, but we will give it here. We're going to say that our answer is going to be y, or we can say f of x, whichever you prefer, is approximately equal to, again, we can't say exactly equal to because we're approximating it and we need a brace. The first branch is going to be this one, so it'll be and we're just going to list the part after the y, so 3 parentheses x plus 3 plus 1. And now that was on the domain from -4 to -3. And I'm just going to use less than signs for now. And we'll go back and have the inclusion signs in a minute. And then the other one, the second branch was -1/4, x minus 1. And that is on the domain from -3 to 1. Okay, and that last line, you should do this on your own, and you should get a 1 x minus 3 plus 2, and that'll be on the domain from 1 less than x less than 3. Okay. Now we need to go back and have equality because notice we have all filled in circles. Well, certainly this is the only place I can have equal here because it's the only branch that contains 4, and similarly over here. Now in between, and I forgot a less than sign here. Now from here on out, it's kind of your choice. I like to put equality signs on these first ones, mainly because I know that this point is included in this one, and so you can have it in both places if you wish, but it's a little redundant. So try and do it in only one place, but that, in short, is how you make a piecewise linear function. And we will continue in studying transformations of functions next.